Well, hi all. Welcome to GradStats 2024 Lab Series. In Lab 5, we were in SPSS, we're working with Chi-Square tests. And the Chi-Square is a non-parametric test used in research when our data are categorical. And we're looking to see if the data frequencies, the frequencies in each of these categorical variables, is significantly different than what we would have expected. Now, the two types of Chi-Square test we'll be working with are the test for independence and the goodness of fit test. And materials you'll need for this lab are the Dataset survey.sav from Pallant and the Labsheet Lab5 for Chi-Square. So grab those items, open up SPSS, and we will get started. Okay, opening up in SPSS, we have the survey.sav dataset, and this is the one where they already kind of set things up for us. The ID is already a nominal measurement type, and we have our totals at the bottom, all of that. So that's the one we're working in. And getting started with our data set, we want to check the variables, make sure everything's fine, and describe the categorical variables of interest. Now for Lab 5, our categorical variables of interest are sex, source, like source of stress, and smoke, as far as do you smoke or not. So typically, when we're looking at categorical variables that we want to describe, we go to descriptive statistics and frequencies. And here, we're just grabbing those three. I'm holding the Command or Control key down to grab multiples that aren't right beside each other and putting them in the frequencies field, and then paste to get our syntax window to pop open here. And I can go ahead and run that. And we have the information here that we had 17 missing in source, we had 3 missing in smoke, no missing in gender sex variable, and then the breakdown. So we're used to this describing the categorical variables in terms of how many and what percent of the whole do they represent in each of these. Okay, now when we're talking about preliminary assumptions for Chi-Square, they're really quite simple. You need to make sure the variables are categorical. Check. We need to know that the sample is randomly sampled from a population. And we don't know that for this data set, but typically you're looking for random sampling when you're looking at data. And that the data are independent. In other words, the person who put in their information about their gender orientation, whether they smoke or not, and their sources of stress, that when they submitted their information on the survey, it didn't impact the next person's. So we're going to assume that data are independent and they're randomly sampled, and we can see that the variables are categorical. So we're all good for preliminary assumptions in terms of Chi-Square. So that's good. And our first task is a Chi-Square test for independence. And this is when we're looking at, is there a significant difference between what we're observing in the data set and what we would expect in terms of distribution of those amounts of frequency if everything was equal, if there was no association between two variables. What would we expect the distribution to be, and then comparing that to what we really have in the data and saying, are those two significantly different? So the first one we're going to look at is a research question like, is there an association between gender and smoking behavior? And again, those two are categorical variables. To run this, we're going to go to Analyze and Descriptive Statistics and crosstabs. In here, we're going to put the sex variable on the rows and the smoke variable on the columns. Now, the reason I chose it that way didn't really matter for this particular analysis because it's a 2 by 2. we only have male and female, and you smoked or you didn't smoke. So either way, the table is going to be pretty manageable. But when you have like a bunch of groups or levels in your categorical variable, then you're going to want that on the rows, because it just makes your table a little more manageable when the more itemed, more leveled categorical variable is on the rows, and the one with less levels to it is on the columns, just for managing it. Now, in the statistics area, we're going to want to say we want a chi-square, and our effect size for chi-square is going to be either phi or Cramer's V. Phi is used when you only have a 2 by 2 table, which is what we have here. When you have something bigger than a 2 by 2, then you're going to want Cramer's V. But in SPSS, they're right there on the same checkbox anyway, so we're golden there. We're going to continue here, and then in cells, we want to select some things. We want observed and expected counts, and on percentages, we want percentages on the row. So we will go with those. We'll hit continue. And here we are ready to paste and see what that looks like in the syntax. So this one's my test for independence, and it's the 2 by 2 of sex smoke. All right, running that guy. And here's my information. So first, one of the model assumptions we want to look at is the expected count. And for a 2 by 2, you're looking at kind of a higher expected count than typical. You're looking for a count of like 10. So do I have at least 10 in my expected cells? So I'm expecting that I should have almost 35.9 males who say yes to smoking, 148 males who say no to smoking. That's my expected. And we want those to be over 10 for a 2 by 2. If it was greater than a 2 by 2 table, like a 5 by 2 table, then we can reduce that expectation to 5. But for a 2 by 2, it's so small, we want to have at least 10 in those expected areas. So we're looking good there, because nothing is under 10 expected. And then just looking at this crosstab table to see what we have. Again, looking at the males here, how many participants are male? For that, you'll go across the row and see the total. We have 184 male, and that should be no surprise because we ran descriptives, and we see that we have an 185. So someplace someone did not report. But I have no missing. Oh, we have missing in smoke. See what I mean? So out of those 3 missing values in smoke, one of them must have been male, because I know I have 185 males, but only 184 told me about their smoking habits. See how those work together? So 184 males reported about their smoking habits. And then if the distribution of smokers among male participants was equal, what would we expect? We'd expect almost 36 males to say they were smokers. Now, what we actually got is 33 males said they were smokers. So is that difference significant? Like, is our sample significantly different than what we would have expected in terms of male smokers? Same thing as male non-smokers. We expected 148, but we actually had 151. Is that difference significant? So here we're finding out about, well, what is the data telling us, kind of our descriptive statistics. Within males, out of the 184 males that reported, 17.9% of them said they smoke. And out of the 184 males, 82.1% of the males said that they did not smoke. So this whole section is only about the males. And then we can go to the same information for females. How many females reported about their smoking? 252. 20.6% of them say they smoke of women, and 79.4% of the women say that they do not smoke. Again, this whole section is only about the females. And then the total is about the whole sample. So out of the 436 that reported, 85 of all of them said they smoke. We were expecting 85, that's good. And that is 19.5% of the sample, the whole sample, are smokers. And 80.5% of the whole sample are non-smokers. So that's very descriptive in nature. And then still, we're getting to the question of, okay, so what about our chi-square test, right? Does that mean that our chi-square, that this expected is significantly different than observed? So for this, we go to the chi-square test table. And what we're looking at for here, because we have a small 2x2 table, and this is the part that gets tricky, we have to look at this continuity correction. This is the Yates continuity correction that Pallant talks about. And this is the chi-square value that we would want to use because the table is Whittle. Okay, so our chi-square is going to be the 0.337 number, 1 degree of freedom, and that's our significance. So our significance, our p-value came in at 0.562. Looks like this is a non-significant chi-square test. And what that means, a non-significant chi-square indicates a relatively even distribution across the categorical variables. So there's no significant difference between observed and expected in terms of gender and smoking behavior. We can conclude that there's no association between gender and smoking behavior according to this chi-square test. Now, we don't have to report effect size when we have a non-significant test, but if we were going to, we can still do it, like we don't have to not do it. But if you're talking about a 2x2 table, you're looking at the phi. So the phi negative 0.034 is the effect size of this chi-square, which is very, very little, 0.034. Think of it very similar to the correlation magnitude, so 0.1, 0.3, 0.5. 0.1 is weak, and this is 0.03, very weak, and which makes sense. Okay, so what does our write-up look like here? Let's take a look. We have our lab sheet, and going down to our example write-up here. A chi-square test for independence was conducted. I let the reader know what type of test we were running to identify potential relationship between smoking status and gender. So now I've let the reader know both the variables being used in this model, and I went ahead and gave them the descriptive statistics about the information. So results indicated no significant association, and there's my chi-square line. So chi-square, 1 is the degrees of freedom, and then you include the sample size that was in the model. So n equals 436. The value of the chi-square was 0.337, so rounding to the hundredths place is 0.34. The p-value was 0.56. And you can go 2 to 3 decimal places with that. Either is fine. And then the phi, the effect size, was a negative 0.03. And then my interpretive closing there with smoking status evenly distributed between male and female participants, because a non-significant chi-square indicates there was not any kind of unequal distribution there between what we expected and what was observed. So that's our first task. Now for task 2, we're going to jump it up a bit. We're looking at, is there an association between source of stress and smoking behavior? And source of stress has a larger contingency table. It's more like a 9x2 instead of a 2x2. So let's go work with that one. Here we'll go to Analyze, again, Descriptive Statistics and Crosstabs. And now instead of sex, we're going to put in source. So the source of stress. Again, you want the chi-square and the phi and Kramer's V indicated in your statistics area. And I can continue there and make sure in your cells area we have the observed and expected and percentages for the row. We can continue and paste. And let's take a look at that syntax. So now we have the crosstabs for a larger table. And let me put test for independence. This one's a 9x2, which is source of stress and smoke. And you can put whatever helps you on your notes, because it's so that you can go back to it and be able to see what you were doing. Or if you needed to run the analysis again, you can just go in and run it right from your script. So now this didn't change much except that I have source instead of sex. And then everything else is the same. So if I needed to run crosstabs for any other categorical variable, I could just go ahead and edit, copy the whole thing and edit the line that has what variables are going into it, instead of having to click through everything. So running this, much bigger table, right? And again, we'll start with checking out some assumptions. We want to check the cell count assumption. Now this requires at least 5. And it does give us a little hint down here in the note of the chi-square test table. It says 5 cells, which is 27.8% of the reported, have expected count less than 5. So that's something to note. That would be a violation. The minimum expected count is 2.34. So we have 5 of these, like here. We're expecting 2.3 people to say that they smoke if they also say that their source of stress is relationship. So relationship source of stress is only expecting 2.3 in the yes I smoke area, and that's less than 5. So that you would want to indicate in your assumption sentence for the chi-square test for this one. The way you would deal with it, if you got more data, maybe these would be higher. So that if we're really having one for every 439 people, then maybe we need to bump that up to, what about 2,000 people to be able to get our numbers up to expected 5. But other than that, looking at these, right? Just looking at these elements of source of stress. This one's 1, this one's 1, this one's 3, this one's 1. And all of these, I'll double click this just so that it stops putting the little note in front of me. So we got spouse or partner, relationships, children, and family. And they're all low. But 1, 2, 3, 4, 5, 6, when I look at all those together, and they're pretty much all about people, right? Your spouse or partner, other relationships, children, and family, these are all people representatives. So I could do a recode and say, okay, I'm going to make a new variable and recode so that anything that was 2, 3, 4, or 5 is now going to be a number, like let's say 10, because I don't have 10 here. And then those would be combined, and I could just call it people even. So the level, I would still have work, and then I could have one called people, one called health and illness, one called life in general, and one called money finances, one called time. That would end up being 6. So I'd have a 6x2 table instead of a 9x2. Now I think that would get us there. Nope, health and illness is still low, but I don't really have anything I could combine that with. So I could run a 6x2 and just let the reader know we have a low expected count for health and illness, and just be transparent. But that's just some ideas on what you could do if you had an assumption violation like that you have some levels of that categorical variable that could be combined together. We're not going to do that. Okay, so that's our looking across expected for each source type of stress. And if the participants indicated that they are smokers or not, and the comparison between count and expected count for each type. But what we need is our chi-square test itself to know if this is a significant difference between observed and expected. And now because we have a bigger table, it's not just a little 2x2, it's a 9x2, we can look at the Pearson chi-square value. So this value, 18.38, is the value of our chi-square. The degrees of freedom are 8, and the significance level is 0.019. So that indicates a significant chi-square because it's less than 0.05, right? So that's good. And then in our symmetric measures area is where we get our effect size. And we have a significant chi-square, so we're going to want to include the effect size. Again, for a larger table, larger than 2x2, we want the Kramer's V. So our effect size is 0.21. Here at the bottom, number of valid cases, our sample size of the cases in the chi-square. That's helpful, and it's right there at the bottom of your chi-square test as well. And you need all those for the write-up. So let's take a look at the write-up for this one. So here, chi-square test for independence was conducted to identify potential relationship between smoker status and source of stress. Now notice how I didn't go and list a whole bunch of descriptive statistics for source of stress, because there's a lot of them. There's 9 of them, and that starts making your narrative very busy. So what I decided to do instead is build a table for that, and we'll look at that in a moment. Results indicated a significant association. So there's my chi-square, my degrees of freedom, the sample size in that test, the value of the chi-square, so the 18.38, and the significance level, and the Kramer's V effect size. Distribution of smoker status was significantly different across various sources of stress. We can, if you haven't already told your reader about the assumption issue, you can tag that on. Of note, there were several expected values less than 5 indicating a violation of assumptions for chi-square. So you can tag it on, or you can put it ahead if you have like preliminary work where you're giving the descriptives of your sample and mentioning that you're going to do a chi-square, but you do want to let the reader know about that. And let's look at that table. And what I'd like to show you there is, so I don't have this particular table on your starter tables Excel, but when you have a lot of information, let's go back to our output here. That's a lot of info, right? When you have a lot of info that you want to condense to a table, one thing that helps a lot is to just go ahead and draw it. You know, do a drawing, get an idea as to what you would like it to look like. What kind of information do you want to share in that table? And then from that, it's easier to set it up the way you want. Like, let me just open up an Excel and let's work with this. Let's work with a blank Excel. I'm going to bump it up so you can see what I'm doing. And I'll try just copying this table. I double clicked it. Let me see if I can just select all of that. I'm doing Command Copy, but then I'm also going to right click and do Copy, because sometimes I'm not sure which way SPSS is listening to me. And then I'll come over to the Excel and paste. Okay, so it's got the information. You know, it's a hot mess, but it does have the information. I clicked on the corner to select the whole table, and then I'm clicking where the little cursor mark does the double arrow sideways, and I'm double clicking on that line between the columns to get it to extend as far as it needs so I can see what it's doing. And looking at my little picture, what I would like is something like, so if I have table 1, so I'm just going to start building according to my picture and then seeing if I can move this information over or copy paste it somehow. So I'm going to speed through this so that you don't have to watch me fumble around, but it's exactly what I'm doing when I'm trying to make a table. So I messed up something here. This is expected, and I wiped out my count. And I'm going to go back and get those numbers from the actual output because this is expected, not actual. Looks like my actual is kind of jacked out up there. So I'm going to grab the numbers I need since these are not the numbers I want. I want 45, 178, 223. Okay, so all the information is in, and this is like just a descriptives table, so I don't need to put in information about the chi-square test on this table. And I need to format the tables that it looks most like in the APA manual are sample table 7.2 and sample table 7.7. So that would be kind of a start of it. And then I can copy paste from here into my Word document. Oops, so I don't want that line to go all the way across. I only want it for these like column headers. So I want it to not have a bottom on this one. It's going to fight me. Okay, that worked. When I just selected these three and did a top border, it seemed to behave better. So, whatever. So I have my table number is bold, my table title is italics. I need to fix these because these were not supposed to be title case. They were supposed to be just sentence case. But there was only 2 letters I had to fix there. And that would be a good little descriptive table that lets the reader know about this breakdown of sources of stress by smoker. Need to italicize that. And I could add the percentage on each of these too with a comma. If I'm going to do the whole count and percentage up here, we could do count and percentage for each one of these. And that would probably be a very full little table, but organized and a little less crazy than putting it right here. So you can send your reader to a table when you're trying to condense information. Okay, so that's playing around with the table. And we have one more chi-square test that we're going to run here. So for task 3, a goodness of fit test. This one's a little different. This is when we compare the proportion of cases in a sample to a known proportion that we know about some other way, either a population statistic or a report from a prior work that had a lot more people in it, something that almost like a norm, like you're comparing your sample to a normed or known distribution of values. So, and you'll also see it called a one sample chi-square because again, you're just have your sample and you're comparing it to a known other. So, and this is goodness of fit. We're not expecting the distribution to be 50-50 like we would be testing in the independence test for independence. It's looking at a equal distribution across those levels of the categorical variable, whereas we might know that 20% of the country are smokers, not just a 50-50, 50% smokers, 50% not smokers. So that wouldn't be a test that makes sense when we're just looking at the smoke variable singly. Like, are the smokers represented in our sample of a similar distribution that we would expect, knowing the percentage or proportion of smokers in the country? Would be more like that. And we often use a chi-square goodness of fit test when you're looking at the quality of model fit in other statistical modeling applications that we're not going to get into this term, but you'll see it used more often, goodness of fit test. So let's run this one. We'll go to Analyze, and now we're going down here to non-parametric tests. Then you're going to Legacy Dialogues and chi-square. So a little different than what we've done before. In here, the variable we're going to test is smoke, the smoker variable. And you see it's expecting all categories to be equal, that 50-50 kind of thing, whereas we're saying, nope, it's going to be a little different. And here, you got to look at how your data are organized. In our smoke variable, 1 is yes and 2 is no. So the order is the yes smokers before the no non-smokers. And that's the order that we have to put these values in to our expected values. So we're expecting 20% or 0.2 for the smokers, and I hit the add, and I'm expecting 80% or 0.8 for the non-smokers, and I hit add. And having those in there, we are ready to paste this and see what that syntax looks like. There we go. So there's our non-parametric test. Oh, goodness of fit test. and it's running a chi-square on the variable smoke. There's the expected values that we gave it. So running that guy, we get a very little table. Here we go, what was expected and what was observed. And the total in this was the 436 in the smoke variable, those who reported their smoking status, right? So this is just one variable that we're checking out, our sample compared against the expected proportions in whatever we had before, whether it's a large paper or prior research or population statistics. And we have that our chi-square was 0.069, degrees of freedom 1, and the p-value is 0.792. So this indicates a non-significant chi-square, which means there's no difference between our observed values and what we expected. They are similar. We have the little note that 0 cells have expected frequencies less than 5, so we've met that assumption check. And this particular one does not even have a effect size that we can get to easily, so even if you had a significant chi-square for goodness of fit here, I wouldn't ask you to figure it out. That would be for a later class. And then let's see how this one gets written up. So goodness of fit, again, telling your reader what kind of test, what went into it, and what was found. So a chi-square goodness of fit test indicated no significant difference in the proportion of smokers identified in our current sample, which was 19.5% were smokers, as compared to the value of 20% that was obtained in a previous nationwide study. And then I tacked my stats line on the end of that. So you see how this is just one sentence. Like, I've already included everything in there, including the test, what it was about, the information, the results line, and it's got the interpretation in there that there was no difference in proportion of smokers in our sample compared to those in a prior study. If you wanted to add another interpretive sentence on the back of that, this would indicate that our sample is representative of smokers in the population in general. Which is good to know. Good to know that your sample seems to be representative. We didn't have any assumption violations there, so you're golden there. Okay, so we covered a lot here. Chi-square is one of the only or few non-parametric tests we're going to be looking at this term. We're also going to look at logistic regression, but I get various information on if people consider that parametric or non-parametric. But chi-square test is definitely a non-parametric test. It's when we have a categorical outcome, and this is a way of looking at, is our data coming in a way that we expected? How well does our model fit the data? So take a look through, make sure if you have any questions you reach out to me, and I will see you at the next lab.